Hello Year 10s, this is Mrs. Elliott's hand. Just going to talk you through the differentiation questions in exercise 16a, just questions 1 to 5. So this whole idea of differentiation, remember with differentiation you are finding the gradient function for a particular function or a particular curve. And that gradient function, if you substitute x values into it, will give you the gradient at any point on your curve, yeah? It has other names. Sometimes it's called the derivative, and sometimes it's called the derived function. I don't think I ever call it that, but sometimes it is. So, the way that you get to that we'll come to in a moment. First question in 16a just asks you basically to fill in some values on a table of values for the curve y equals x squared minus 2x. Here's one I've prepared earlier. And here are your x values and here are your y values. What I usually do when I look at one of these is just check that they've done it right and that I therefore understand what the question is asking. So I'm pretty certain that my y values are going to be derived from y equals x squared minus 2x. Substitute in minus 2, one they've done for us. Minus 2 times minus 2 is 4. Minus 2 times minus 2 is plus 4, so that's how they got their 8. So I think I understand the process. So I'm just substituting in x values. X equals 0 is going to give me 0. X equals 1 is going to give me 1 minus 2 times 1. So 1 minus 2 times 1 is going to give me minus 1. And then 2 squared minus 2 times 2, that's going to be 4 minus 4. That's going to give me a 0. Now, I would have expected a bit of symmetry with this table of values, and the reason I would have expected some symmetry is I know that quadratic is going to give me a parabola, a U-shaped curve, and that it is symmetrical about its minimum point. So I can see that my minimum point here is at 1 minus 1, so I'll just pop that onto my graph. There's 1 minus 1. 2, 0 and minus 1, 0. Sorry, no, not minus 1, 0. 0, 0, the origin are the next ones. Let's just get rid of that. That's the beauty of using a whiteboard. And then I've got 3, 3. 3, 3 is going to be about there, and 4, 8, which is going to be somewhere sort of roughly up there. This is not going to be the most accurate thing ever. Minus 1 is also going to take me to 3, and minus 2 is also going to take me to 8. So I can go roughly up to the right place. Okay, so remember that when we're trying to draw a quadratic, we've done this before, we try and make it a nice smooth curve. Try not to make it fat-bottomed or flat-bottomed or pointy-bottomed. Try to make it a nice smooth curve. That's probably as good a job as I'm going to do. So this is the curve y equals x squared minus 2x. Now we discussed in class the fact that for a curve, the gradient of the curve is changing all the time. Here it's quite steep and negative, still quite steep and negative. Less steep, less steep, less steep. The gradient is actually 0 at that point. Remember, the gradient is represented by, if you were to draw a tangent at any point, there, a tangent there, steeper tangent there. And then these are positive tangents, positive gradients going up this way, but again, changing all the time because it's a curve. Okay, so the beauty of of differentiation, golly, I can't say anything today, of differentiation is that it gives us a function for the tangent gradient at any point, and we represent that. If we've got something originally in the form y equals, we represent the gradient function as dy by dx. And the process, which I think all of you managed to get to grips with very quickly in our lesson, was that you take your power and you multiply that by the coefficient. Now the coefficient here is 1, so that becomes a 2x, and then we reduce the power by 1, so it's just 2x to the 1, so that's just 2x. And then for minus 2x, So our power is 1. We multiply through by that power, so that gives us minus 2. And we reduce the power by 1. That takes it to being a 0. So that x just becomes a constant on the end there. Okay, so that's our gradient function. And then they basically just want the gradient of the curve at various points. So I want my gradient at 3, 3 and at 4, 8. I'm asking for the next 2 points. So the value that we're interested in is the x value, x equals 3 and x equals 4, and we literally just substitute them in. So gradient equals 2 times 3 minus 2, which is going to be 4. Yeah, and here the gradient is going to be 2 times 4. Oh, okay, I'll do them both in brackets. 2 times 4 minus 2, which is 6. Part F of the question, 2 more points on the curve, where you can choose any points on the curve. So I did actually prepare this one earlier. So if I say at minus 2, 8, my gradient is going to be 2 times minus 2 minus 2, which is minus 6. And I've also done at minus 1, 3. So the gradient will be 2 times minus 1 minus 2, which is going to give me minus 4. Now, let's just have a quick look just to make sure that these sort of make sense. So on our graph, at the point where x equals 3, there's the point that x equals 3, we've got a positive gradient of 4. Yeah, could easily be that from this graph. If we were to draw a tangent there, put a right angle triangle on it, could easily be 4. And more to the point, when you go a little bit further along the curve to where x equals 4, it's steeper. So we've gone from a gradient of 4 to a gradient of 6. That makes sense. Similarly, at these 2 points where x is minus 2 and x is minus 1, so at x equals minus 2, we've got a gradient of minus 6, very steep gradient. And when x is minus 1, it's minus 4. Still pretty steep, but not as steep as it was there. So it does make sense, and they're in the negative direction. So that's just a little check. Part G of the question, at what point on the graph is the gradient 0? Well, I think it's going to be at this point here, because at that point there, if we drew a tangent to the graph, the tangent would be horizontal. A horizontal line has a gradient of 0. However, I'm just going to prove it by setting my gradient function dy by dx equal to 0. I'm just going to check that this is still on the screen. Yeah, you can still see that. Okay, so if dy by dx equals 0, then 2x minus 2 equals 0, 2x equals 2, and x equals 1. So at x equals 1, we know that the gradient is 0. I think they wanted the actual coordinate of the turning point. We know that when x equals 1, if we substitute it back into our original equation, we get minus 1 as being the y value. And then the last bit of the question, by looking at your graph, check that your answers to parts D, E, F and G seem sensible. Well, we've sort of done that as we've gone along, haven't we? So I can just say yes, they are. Okay, so hopefully that sort of just explained that whole process to you. Right, let's move on to question 2. So I'm rubbing this one off. Question 2. So no more graph drawing. Thank goodness, I know we don't really like graph drawing that much. So question 2, so we've got y equals x squared minus 6x plus 15. Always write out your y equals. Yeah, first thing you do, write out your original function and then work from that. Part A, work out dy by dx. So we're just going to go through the process. We're going to bring that power down in front, multiply the coefficient by it, reduce the power by 1, so it's just 2x. And then do the same here. Power is 1, so we've still got a minus 6, but the x is to the naught, so it's disappeared. So dy by dx is 2x minus 6. Gradient at 0, 15. Gradient at 0, 15. So what we're interested in is x equals 0. So your gradient, or your dy by dx, is going to be 2 times 0 minus 6, which is going to give you minus 6. Gradient at 510. Gradient at 510. So again, you're just interested in the x-coordinate, sub that in, x equals 5. So your gradient function is going to give you 2 times 5 minus 6, which is 4. So those are your two gradients at those 2 points. Find, oh no, that was C. D, I'm on. Find the coordinates of the point where the gradient is 2. So we take our gradient, so we know that our gradient equals 2. So we take our gradient function, 2x minus 6 equals 2. So what we're basically saying is dy by dx equals 2. And we just solve this. So 2x equals 8. X is therefore equal to 4. Substitute our 4 back in because they want the coordinates. So y is going to equal 4 squared minus 6 times 4 plus 15. 16, 31 minus 24, y equals 7. So the point that we are interested in is the point with coordinate 4, 7. That's where the gradient equals 2. Okay, right, question 3, very similar question. Question 3. So question 3, y equals 2x squared minus 10. First step is always to write out your original function. Part A is to differentiate that to find your gradient function or your derivative. So bring the 2 down, multiply the coefficient by it, you'll get a 4. The 2 becomes a 1, so that disappears. The minus 10 is just going to disappear. Remember, a constant line has a 0 gradient. So the line y equals minus 10 would look like that on a graph if that was your x-axis, and therefore the gradient is 0, yeah? Okay, so dy by dx is 4x. The gradient at 2 minus 2, so x equals 2. So dy by dx is going to equal 4 times 2, which is 8. And the gradient at minus 1 minus 9, so we're interested in the x value only still. Same thing, substitute in x equals minus 1 this time, 4 times minus 1, so we're going to have minus 4 as our gradient. Part D, find the point where the gradient is 12. You know what we're saying here, then we already know our gradient equals 12, so we can say our gradient function equals 12, x equals 3 at that point. Now we need to substitute x equals 3 back into the original function in order to calculate our y coordinate. 2 times 3 squared is 18 minus 10, that equals 8. So our coordinate at which the gradient is 12 is the coordinate 3, 8. Okay, question 4 next. So question 4's got a graph on it. So we will be just using that graph. I'll just do the world's quickest ever sketch of the graph just so I can refer to it. So it's a negative parabola going through the x-axis at 0 and 4. And that point there is at 2, 4. So those would probably be the points that we need to refer to in the question. So this is question 4. So here's a graph of y equals 4x minus x squared. Yep, that makes sense. Goes through the origin because when x equals 0, y equals 0 for this. And it has a negative quadratic shape. That makes sense. And also, if we were to factorize it, oh dear, Mrs. Elliott, x minus 4 is what I was trying to, no, 4 minus x would be a better way of doing it. 4 minus x, so if we set that equal to 0, we know passes through the x-axis 0 and 4, yeah, so it doesn't make sense from our graph drawing times. So first thing, work out dy by dx. That's going to become 4, and that's going to become minus 2x. Gradient at each point where the curve crosses the axes. So at x equals 0, dy by dx equals 4 minus 2 times 0. So that equals 4. That sort of makes sense. It's a positive gradient there. And then the other point is at x equals 4. And that's going to give us 4 minus 2 times 4, which is minus 4. And that sort of also makes sense. This is a symmetrical graph, so where we've got the graph going through the axes at a positive gradient that way, it's going to be the same gradient but negative the other way. Obviously it doesn't look like it from my rather rubbish drawing. Where is the gradient equal to 2? So the gradient equals 2, and dy by dx equals 2. So dy by dx, 4 minus 2x has got to equal 2. So if I subtract 4 minus 2x equals minus 2, divide through by minus 2, x equals 1. So gradient equals 2 when x equals 1. And we just need to sub in to find out y value at that point. I'm just trying to sort of squeeze this in here. Y is 4 times 1 minus 1 squared, so y is 3. So our point is at 1, 3. Okay, see if I can squeeze in d. Where is the gradient equal to 1? Exactly the same idea as the previous part. Dy by dx equals 1. So 4 minus 2x equals 1. I'm just going to subtract the 1 and add the 2x. So 3 equals 2x. 3 over 2 equals x. Okay, so we've got a fractional value for x. So we're saying that the gradient is 1 somewhere here. And that sort of makes sense. It is positive at that point. So subbing in, y equals 4 times 3 over 2 minus 3 over 2 squared. I prepared this one earlier, so it's a 15 over 4. Yeah, either by calculator if it's a calculator paper, or by doing some work with your fractions there. So your coordinates will be 3 over 2 and 15 over 4. Okay, so last question, question 5. You're just working out the derivatives for all of those, so I will just talk you through them, but hopefully you're sort of okay with all of that. Yeah, I'm about to rub it all out. Let's see if I can fit them all on one. I don't know if I can actually. I'll draw myself a centre margin, that always helps. Okay, so 5a, y equals x squared plus x plus 1. So differentiating, x squared becomes a 2x, and that x just becomes a 1. Yeah, the 1 will disappear off the end. The x just becomes the coefficient of it, which is 1. Okay, 5b, x or y equals even x cubed minus 7x plus 3. Same process. So we bring down the power, reduce the power by 1, and subtract 7. The 3 will disappear. Yeah, the x just becomes a 1. C, y equals 4x squared minus x plus 6. So we're going to bring down the power, multiply the coefficient by that power, it becomes an 8. And then the coefficient is reduced by 1. And then we've just got a minus 1 because we've got a 1 as the coefficient, and the coefficient was 1, becomes a 0. The 6 disappears. Let's draw some lines under these. I'm hopeful I might fit it all in. D. We've got some fractions, or other decimals, don't be put off by them. The process is exactly the same. So we're going to bring our power of 2 down and multiply our coefficient by it, so it becomes 0.6, just an x on its own, and minus 1.5. Yeah, same process as the ones above. E, y equals 6 minus 2x plus x squared. Don't be put off by the fact that they've written it round the other way. So the 6 is still the constant at the end, so that's going to disappear. The minus 2x just becomes a minus 2, and the 2 and the x squared just becomes a 2x. F, y equals 10 plus 3x minus x squared, still no different to the process we talked about with this one down here. The constant will disappear, the 3x just becomes a 3, and watch out for the negative sign, the x squared becomes a 2x. Okay, G. We've got y equals 2x plus 5. Don't be put off by the fact that it's a simple linear equation. 2x plus 5, the 2, x just becomes a 2. If you think about it, this is just a straight line. It's going through the y-axis at 5, and it's got a gradient of 2. We know that because that's what we would do if we were just putting it into y equals mx plus c format, isn't it? Yeah, so we would know that that gradient is 2. And indeed, when we differentiate it, that's exactly what we get. And finally, y equals 4. So again, just think about it from a logical point of view. If that's the x-axis, the line y equals 4 is there. It's got a 0 gradient. This is just a constant. We know when we differentiate a constant, we get 0. So that's our last one. Okay, hopefully nobody has had to watch this video because hopefully everybody's been happy with these. Okay.